Dear learners, this is the first live session for this course, Advanced Thermodynamics and Combustions. I welcome you all for this live session. So as per these things, we have two people, Saban and Dheeraj. So I now request you, by now you have already completed almost 3 weeks lecture. I expect that you should share your views. If you have any queries in any of the video lectures at any point of time, please feel free to share your views. If you have any questions, please come forward. So if you have no question, then I'll share some of the queries which were raised during this discussion forum. First of all, I invite you all for this online certification course under NPTEL platform from MHRD program. And in this MOOCs course on Advanced Thermodynamics Combustion, by now we have completed almost 3 weeks, and I hope you are enjoying this course. Now, in this, for a few minutes, I'll just share some of the questionnaires which were raised in the discussion forum, very specifically about the course content, PPT slides, all these things. And there are some kind of general queries I thought of explaining you in this live sessions. The first query was based on the lecture number 1. The learner just wants to know about the temperatures, concept of temperatures. And we all know that temperature, internal energy or energy content of this taken is a function of temperatures. The kinetic energy and potential energy of the entire systems for which temperature was not part of these calculations. But what was these things? Somehow I could not make out what is the learner wants to know. This is regarding the coordinates, and a particular notation has been used for a microscopic view. Okay, so regarding this is regarding microscopic and macroscopic approach for defining the temperature of the systems. So in our to talk about microscopic approach, we actually look at the kinetic theory of gases, where individual molecules, its locations, and its specific properties were taken into account. So in that context, if I say in a microscopic approach, the entire medium is given a coordinate systems xi, yi, and zi, and one such parameter could be temperatures. So temperature at xi location, yi, this temperature can be a different with respect to molecule to molecules. So that happens in a microscopic approach. But you should not worry about this microscopic approach, because in our entire course, we call this temperature as a global property and it is a macroscopic property. When I say macroscopic properties, that means we have taken enough mass or minimum, we have already have minimum number of mass for which the global temperatures of will not change. Very basic, in a single line answer, I can say temperature in our course is considered as a macroscopic property and it is to consider as a global nature, the system. The next question was on quiz 1, question number 7, where the question was asked, what are the correct statements for the Carnot cycles? Carnot cycle options are the Carnot cycle is independent of upon the working substance. Carnot cycle can have 100% efficiency. Carnot cycle is represented by 2 isothermal and 2 adiabatic processes on a PV diagrams. But the learner wishes to know whether what happens to the source and sink temperatures. First of all, we have not asked anything about the source and sink temperatures. But when you talk about 100% efficiency, of course, sink temperature has some finite value. So when I say some finite value, that means we are looking at the problem in a practical approach. So based on that, the efficiency of the Carnot cycle mainly depends on the source and sink temperatures. That we can write is as efficiency is nothing but 1 minus T2 by T1. So from this efficiency and when it will have 100% efficiency when T2 goes to 0. So that's a very hypothetical approach. That means Kelvin temperature goes to 0. That's not a case situation, and that cannot happen in a realistic or practical approach. And this efficiency is the maximum possible efficiency, or we can say thermodynamic estimate of maximum efficiency with respect to Carnot cycle. So considering this philosophy, and we can say option A and option C are correct. So the correct statements we can write in this manner. The next queries was based on the quiz 2, question 10, where we talk about a reversible cyclic engine. 2 heat sources. One is a finite body. This finite body is at 900 Kelvin. We can say T1 is equal to 900 Kelvin. And this, it is embedded to a heat engine. And it's a cyclic heat engine or reversible heat engines. And this heat engine produce some work output while rejecting the heat to a reservoir which is at 300 Kelvin. And heat capacity, that is Cp for the body, is 1.048 kilojoule per kg Kelvin. So based on this, we can say it's a heat engine. It operates in a cyclic manner. So entropy for this engine is 0, and delta S body we can find out Cp is equal to ln T2 by T1. So based on this, our answer is minus 1.1513, which means the body is losing heat. So that is what the change in the entropy for the body is in a negative side. Okay. So to be clear, for the heat engine, is the question asking about increasing the entropy strictly to the inbound heat flow, or does it net effect? So we are not asking, we are asking about the entropy change for the body. With respect to body, we are changing the entropy for the body. So that is what the question was asked. The next query was mainly on lecture 7. So it's a big statement the learner wishes to share. But for few things that we are not clear about in what context it was the question was raised. If I can say sense some of the important concept about the entire paragraphs which was written by the learner. The first thing is it is pointed out something about heat loss. So the heat loss somewhere in this talking about a heat loss outward for the system. And when I say heat loss, it's a by loss it means it's a negative quantity. And one of the way that how we can approach this in a we have to recall our basic understanding about the conventional approach. And in fact, we have to look into or deal with the UG level of this course about the notation of the notations about work transfer and heat transfers. So in a conventional approach, work transfer by the system is positive and heat transfer into the system is positive. So work transfer by the system means system does the work, and when some heat is entering into the system, it is taken as positive. So both heat and work needs to be looked into simultaneously. Now, when the work transfer on the system is negative, then at that point of time, and when heat transfer out of the system is considered as a negative. So the word negative stands for work transfer done on the systems, heat flows out of the systems. So, or heat flow out of the system means it's basically loss. So implicitly, when I say heat loss, by default, it's a negative. Second point, the learner wishes to know about nozzle actions and diffuser actions. So I must say that you must be very clear what do you mean by nozzle actions and what do you mean by diffuser actions. And you should not be you should not be confused about the passage shape and size. So basically, irrespective of what situation it is, whether subsonic flow, supersonic flow, or incompressible flow, compressible flow, the nozzle action implies increase in the velocity at the expense of pressure, while diffuser action refers to the decrease in the velocity through increase in the pressures. Now, both nozzle action and diffuser actions can be controlled by designing the passage. So the passage can be convergent or divergent. Now, if you are considering an incompressible flow, mainly liquids, the converging passage implies increase in the velocity and it gives a nozzle actions. Whereas diverging passage implies decrease in the velocity, which means a diffuser actions. Okay, so this is about this is very with respect to incompressible flow. What does the converging and diverging passage do? But however, the one can, depending on the pressure conditions in the upstream and downstream, the converging diverging passage can as well perform nozzle actions. And typically, we call this as a D-level nozzle. And it is applicable for incompressible as well as compressible flow, which means D-level nozzle is very common when you talk about a steam power plant or steam nozzles. And here the that nozzle is mainly with respect to the Bernoulli's theorem, but Bernoulli's equations has to be followed, where we have a converging passage followed by a throat, and then subsequently we have a diverging passage. So that is true for the incompressible flow. And similarly, for compressible flows where we are dealing with gases due to change in the density and pressure difference between inlet and exit, we can have the converging diverging passage which can perform the nozzle actions, and same thing we also refer as a D-level nozzles. This is the only way that through a converging diverging nozzle or D-level nozzle, one can achieve supersonic flow in a compressible medium. So many times we call it as a supersonic nozzle. And in the similar context, same converging diverging passage can as well perform a diffuser actions, and typically it is very known as subsonic diffuser in many practical situations or compressible flow situations. And this and with respect to incompressible flow, if one question was raised whether this appropriate, whether diffuser or diverging nozzle is something closely related to diffuser action or not. The answer is very true that the diverging nozzle implies implicitly about the diffuser actions for incompressible flow. But however, the word instead of diverging nozzle, diffuser word seems to be more appropriate. But there is nothing wrong if you use the word diverging nozzle. But because it is performing a diffuser actions, we can say it is true that entropy at the exit is less than the inlet entropy. So this is what I can summarize about this big statement of these queries. I hope it will understand, and learner will understand. And mainly this was dealing with the problem which was raised in the question number 8 in quiz 3, where we are looking at steam nozzles and steam enters in a diverging nozzles. Here the word should have been steam enters to a diffuser, because if you look at the data, the steam at the inlet and exit velocities at 447 and 23 meter per second. So basically speed is decreasing. So I thought, so it should have a diffuser would have a right approach. But however, since the problem has already been defined through diverging nozzle, there is nothing wrong if I say diverging nozzle, which actually performs a diffuser action by reducing the velocity. And if you also see that, if you see also the parameters about entropy, we can say entropy at the inlet is 7.25, whereas the entropy at the exit condition is 6.84, which is less. So this is this was the confusion. But anyway, this as far as the frame of problem of this nature of the problem is considered, it is true, and data are also. I mean, with this data, we can find out the using the basic equations of continuity equation. We can calculate the mass steam flow rate. We can also calculate the steady state energy balance equations to calculate the heat transfer, and here it's a loss. Here it is a loss. Since it is a Q out, it's a loss. So it's a when it's a loss, already this Q out is a negative quantity. So implicitly, if I give the positive number also, it's a loss, means by default implicitly it means a negative. And from this entropy balance equations, we can see that entropy generation rate is also a positive quantity. Exergy loss also, exergy destruction can also be found out. The next question was raised about the question number 6 of quiz 3, where the queries is entropy transfer can takes place by mass also. That is true. So from these questions, we can say that in the absence of any irreversibility, the correct statement or options are A, B, C, and entropy is transferred only by heat for a closed systems. That is what option D we are not considering. So, but entropy transfer by mass can take place for the entropy for the open systems. Next questions to clear the doubt about the third bullet point of this graph. regarding the slope of the fusion curve, which can be positive or negative. Of course, which means decrease in the temperature result in increase in the melting. That is not a right frame. You should talk about what happens to pressure. Decrease in the pressure, so will increase in the melting point temperature. So and because this y-axis is nothing but the temperatures, and this temperature, okay. So to do that, let us first understand what we mean. So you have to recall the basic UG course to study the properties of pure substance. And when you talk about properties of pure substance, we usually recall this the property diagram. These property diagrams, they are pressure volume diagrams or pressure temperature diagrams. And this pressure temperature diagram is called as a phase diagram. And when you talk about the substances pressure volume diagram, you can see for some cases some substance that contract during freezing and some substance that expand during freezing. A typical example for this case is water. So if you see, this water is a typical example because they expand during freezing. Now let us recall about this phase diagram which was given in this particular slide. So here we are talking about the phase diagram, pressure temperature diagrams. If you look more closely, it talks about the sublimations, three phenomena, mainly sublimations, vaporization and melting. And when you say sublimations, it's a direct change between solid and vapor or gas. When I say vaporization, it is a phase change between liquid and vapor. And when you say melting, it is between solid and liquid. So this is what these things. What do you look at? If you look the curve on the sublimation curve and vaporization curve, and if you are increasing the temperature, or in other words, if the sublimation temperature or vaporization temperature increases, or in other way I can frame this, if the pressure of this medium of the fluid liquid decreases, substance decreases, then what happens is sublimation temperature increases until triple point, and beyond triple point, if further increase, either it can go as a melting line or it can go on a vapor line path. Now, if your pressure and temperature conditions are such that it can go as a vaporization situation, then vaporization curve with increase in the temperature or decrease in the with increase in the pressure, temperature also increase. Now, if at all they wanted to have, if the pressure temperature conditions are not, that means along the sublimation vaporization curve, it can go in this manner. Now, from the solid to, instead of solid to liquid, there are two ways it can go. And in some cases, if you see the melting line, there are two lines here. One category falls the substance that expand during the freezing, that is something like water. And if you look at here, by decreasing the pressure, the melting temperature increases. So that is a negative slope. So because this substance expand during the freezing, but if you go along the line, some other substances, it will have a positive slope. So what I can summarize is the slope of sublimation and vaporization curves for all substances are positive, but slope of fusion curve may be positive or negative. And this water in particular has a negative slope fusion curve because it expands upon freezings. And to frame a correct word, we can say decrease in the pressure will increase in the melting temperature for the substance that expand during the freezings. And some examples are water, graphite, and bismuth. But all other substances that contract, they will have a positive slope. So the reverse statement will come true. So I hope you will understand this meaning of this. Okay, this is all about the queries that were given in this things. Now, if you have any queries, you can raise your write your questions in the chat box so we can have discussion. We have already closed 35 minutes. If you have any further queries, please type your questions or raise your queries. We do not have much time. Learners, please raise your queries. Quiz 8, question 3. Okay, here we are talking about atmospheric temperatures. Quiz 8, question 3, and the atmospheric temperature comes about T0. Okay, there is a missing data for T0, but however, if this answer was calculated based on T0 is 278 Kelvin. Now here I will suggest that although there is a missing data, but when I say this dead state, the dead state was particularly in the when we calculate the exergy, we normally refer to the dead state. And dead state, in fact, all the groups in our lectures, we said that dead state is typically considered as 1 atmosphere, or we also call temperature as 300 Kelvin. Okay. Since there is some data was missing, so any value between, if you take T0 as 278 Kelvin and T0 as 300 Kelvin, within this range, whatever value we'll get, we will consider for calculating this entropy balance equations. So these numbers will be dependent on, this number will have a answer range. Answer range for these two temperatures. And this, in this case also, will have some answer range from T0 to 78 Kelvin and T0 as 300 Kelvin. So any answers fall in that range will be considered for evaluations. So I hope it answers my question. So you should not be panic about these aspects. We are already considering answer range, not a fixed answer. You should be aware that in our entire calculations, wherever there is some calculations or some, we are not exactly sticking to the fixed answer. We are talking about answer range. So any number, if you have considered in this for the temperature, you will be and your answer falls in that way, we can have that. I hope I have answered your queries. Any other questions? We are now left with 10 minutes. Can we explain question 3, quiz 3? I really do not know whether it is in this slide or not. Question 3, quiz 3. So I don't have the questions here. So these are the questions which were raised in the discussion forum. I do not have the details as of now. Question 3, quiz 3. Whatever were discussed in the discussion forum, I have compiled this for the common understanding. We have 5 more minutes. Another 3 minutes, 3 to 4 minutes. Okay. If there is no such questions, I think we should close this live sessions. But if you are, I hope you are enjoying this course, and hopefully, please do participate in writing your questions, queries in the forum, and so that it will be common so that we can discuss in the live sessions. And also, I request you to go through these assignments in a sincere manner and drop them at right time. With this, I hope we will do success in this course. And thank you for your attentions. So with this, let us conclude our live sessions. So we'll meet in the, if you have any other further discussion is to be done, we can have another live sessions in after 1 month. So come prepared. Thank you for your attentions. So let us close this program.